Okay. So we will start. Uh, Yesterday we have seen the structured data loading, like how basically we load the CSV data that we have seen yesterday. Now today, what we will do, we will load the semi-structured data. Okay. So we will load two type of semi-structured files here. So let's start. First of all, I'll create a database here called nested JSON. So, okay, and whenever we load a semi-structured data, semi-structured data is nothing but like it's a key value pair. Okay, it's a key value data. I will show you how the files look like. So before that, I'll go to the AWS. I'll go to the S3, and whatever bucket we created yesterday. Started recording, right? Yeah. Whatever bucket we created yesterday, I will open the same bucket. So let me open. So this is the bucket we created yesterday. So I'll open the same bucket. And here already we have a CSV folder. I'll create another folder here. For an example, let's say that was the structured data. Now today we are loading JSON, Parquet, Avro, like semi-structured data. So what I will write here, I will write here semi-structure. Like that I'm writing the folder name. Okay. So you can write any name as a folder name. So I'm just writing semi-structure as a folder name, and I'm just creating the folder so that we can understand. So this is the semi-structure. I'll go into the folder, and here what I will do, I will upload my files. So let's go to the files section, and here I will go down little, and we have some JSON file. I'm loading one JSON file called person_JSON, and let's upload. Go to that folder. Now you can see in that folder, in that semi-structured folder, we have this person_JSON file. Okay, just a minute, guys. Now this file will be loaded to my table. So I'll show you how the files looks like. So before that, what I will do, I will create a table called person, and that tables will be having one column called person_data, and that column's data type should be variant. What is the variant data type does? Variant data type is nothing but like it's a universal data type in Snowflake. Whenever we load any semi-structured data, so basically the entire file can be loaded into a single variant column. So this is a universal data type. It can store any type of other data. And that is the reason this variant data type should be used here. Okay. So whenever you get a semi-structured file, so your first activity will be load the file into a column called variant. So the data type of the column should be the variant type. Okay. So let's create a table called person where we have a column called person_data, and data type is the variant. So let's create it. Now, what is variant data type? Variant data type is nothing but it's an universal data type in Snowflake, which can store any type of other data. Okay. So I created the table. Now I'm going to create the file format. So basically, remember here, I'm not establishing the connection again, because yesterday we already established the connection. We already created the storage integration object and all. And that's the reason today we are not doing all those steps, because we are accessing the same bucket. Inside the same bucket, we created another folder. And that's the reason it is not needed to create another storage integration object and all. So if you remember, yesterday we created the storage integration object till the bucket level. Now under the bucket, whatever files, whatever folders I will be creating, all will be accessible by the same storage integration object. And that is the reason you don't need to create the storage integration object every day. That is the connection related activity. So we'll do one time and we will be using for longer time. So that's the reason yesterday we created, and today we will be accessing the same only. We will not create a new one. Okay, so anyway, so after that, what we'll do, we'll create the file format. Why the file format creation is needed? Because the yesterday I was loading the structured data CSV, so I created the file format according to CSV. Now today we will load the JSON data type. So that's the reason I need to create another file format, and type should be JSON, because file format will be telling Snowflake that what type of files we are loading. So today we are loading JSON file. So we are creating the file format with the type JSON. Okay. So let's create the file format. If I open the schema, you can see here table file format both has been created here. Okay. Now we will be creating the stage object. So yesterday also we created one stage. Now because yesterday our file reading folder was this CSV. We was accessing the folder CSV to load the data. Today we will be accessing the semi-structured folder to load the data. So I need to copy the URL, and from here basically what I will do, I will paste. You can see URL is equal to s3:/ then batch 630, then semi-structure is the folder. From this folder we will be loading the data. That's the reason this folder has been taken. Storage integration s3_int, which I created yesterday, and that is what I am using because we are accessing the same folder, and that's the reason we are accessing the same storage integration object. Okay. And file format is equal to JSON_format. Just now we created. So all the information we are providing here, and we are creating the stage. So you can see the stage got created. And once the stage got created, I will be writing list@stage. So you can see I am able to see the person.json file loaded into this folder sitting from the Snowflake ground. So I can easily say that connection has been established properly. Now simply we will be loading the data into the person table. So let's load. So I'll write here copy into person from ext JSON stage. It's a simple copy statement, copy into person. So person is nothing but the table which I created here with the data type as a variant with column person data. So I'm loading the file. That means this person.json file I'm loading into this person for table. So let's create and let's copy the data. Before that, I'll select the virtual warehouse and I'll execute. So you can see your data got loaded successfully. And once the data got loaded, now if I check the person table here, so you can simply see this is the data has been loaded here. Now this is the entire file actually loaded into the Snowflake table, person_data column. Now I'm copying this value here and I'm going to the another worksheet here. And you can see this is what your file looks like. Okay, the entire file which was loaded into the S3 bucket, the entire file I loaded into the table, and this is the file looks like. The file looks like an array. So basically, this is the root clause of the array, or you can say this is the name of this array. And the first, I will show you why I told you that this is the looks like an array. So from here, this person file is containing 3 persons data. Okay. Now first person's data started from here. The person age is 22. First we will understand the file and then we will break the file into the row column format. So basically first you can see it is started from here. Okay. And you can see first person age is 22. Okay. His age is 22. He is having children. Okay, so remember one thing here, you have to understand which one is the one to many relationship and which one is the one to one relationship. One to many relationship is nothing but where we have the loop inside the JSON, and this type of file we call as a nested JSON file. Nested JSON file in the sense we will be having loops inside the file. What is called loops? So for an example, let's say a particular person can have only one single age. He cannot have multiple age. So that's this age is a static value. That means one to one, a person. This file is about person. Now a person can have single age. So that's the reason this age is a static value, right? But a person can have multiple child. So this is not a static value. It is a basically one to many relationship. One person can have multiple child. This is what we call loop inside the JSON file. So you can see a person can have single age, that's fine, but a person can have multiple children. So this children entity started here, and you can see this is one child details. So child age, gender, name completed. Now another child details started, and child information completed here. Now after that cities live. This is also one to many. This is also another loop, because a person can live in multiple cities. A person can live in multiple cities. So this cities lived is having again multiple value. You can see this is the first value. Similarly, this is the second value. This is the basically, and also remember this cities lived, and in the inside the cities lived we have two things. One is place, another one is years lived, right? Now place, see, for a person to cities lived, if I find out the relation, that is one to many. One person can live to multiple cities. Similarly, each cities that person can live to multiple year. So that means cities live to years live, that is also one to many relationship. A person, a city, a person can live into multiple city, and each city they can live into multiple years. So years lived is another loop. So this loop you have to understand properly in the file. Okay. So now you can see after that full name. Full name is the single value, gender single value, kind single value, phone number also single phone number provided. So these are all single value, static value. Okay. After that here first person's data completed. Now second person's data started, and again his age is 35. These are all the children details. These are all the three children is there. Children details completed. Now cities lived. Now you can see years lived is multiple value we have. So the person can live to multiple place. Similarly, the person can live into one place to multiple years. Like Los Angeles, that person lived in 4 years. So that year's value has been mentioned. So years is an another loop. Similarly, this place, these are all the years, and like that, multiple places, multiple years has been provided. After that, full name, gender, kind, phone number, all the details provided. These are all the static value completed. And after that, you can see the age, another person's data started, age. This person doesn't have any child. So that's the reason children values are not there. Directly cities live values are there here. And once that is completed, then all the static values are there. Full name, Anna, gender, female, kind, person, phone number, and completed. This is the three persons data available into this entire file. Now this file we will be breaking into row column format. So how we will do that? So basically, first of all, what you have to do, you can see in this file we have three column, three value. Now that three persons data all are coming into a single row. You can see three persons data all are coming into a single row. If you check, all the three persons data are coming into a single row. Now if you check here, if this root clause, if you check here, now you can see this is called an array. Like I will show you how it is looks like an array. You can see this is 0 position. This is 1 position. Sorry. uh, this is two position. You can see this is 0, 1, 2. That means you can see here 3% data is there. In the root clause, we have 3% data 0, 1, and 2 second position. So this is we call as position. In the first position, basically you can see 0th position, you have the first person's data. In the first position, you have the second person data. In the second position, you have the third person data. That's the reason this is called as an array. This file looks like an array. So first, what you have to do, you have to remove this root clause from the file, and each person's data we need to bring into a single row. That is what I need. For now, all the person's data are coming into a single row. I need here 3 row will come. Each person will be having each row. Each person's data will come to a each row. So to do that, we will be using the flatten function. Okay, flatten function. Okay. Now this flatten function, how it will be working, I'll tell you. So for an example, let's say this is the query. I'm running this query separately so that you can understand. These are all the inbuilt function. Okay, and let's say t dot star. What I'm doing, I'm writing select t dot star from person. Person is nothing but this is the table called person, which is already having this value. Okay, where we already have stored the entire file data. That is the table name called person p. And I'm using a flatten function as a this is a tabular function. Tabular function is nothing but the function which returns multiple value. You can see this is the flatten function. Inside the flatten function, we have taken p dot person data. P is nothing but person table is called as in p. The alias is p. P dot person data. Person data is nothing but the column of this table, person data. And I will be taking the first root clause. That means which is actually the basically the top most clause. So like this way. So you can see here the root is the topmost basically this is the root category, right? Under this root all the values are binded, so that clause we will be taking here. So that name we will be taking the root category name, the root name we will be taking here. So here we have taken that root. Now if I execute this query, what we will get, so t dot star means whatever this function will be returning, that I want to see in a select clause. Okay, and if I execute this one, you can see that this flatten function taking this person table, the column, like it is taking the person data, that means the entire row column value it is taking and breaking into a 3 different row. You can see root 0, that means first position we have the first person's data, so that is the first person's data are coming. Now the second person's data are coming. Now the third person's data are coming, and this value column has been returned by the flatten function. Okay, now we are getting each person's data. You can see age 22, age 35, age 44. So we are getting each person's data into single row. So that is what we are doing. So now we had the root 0, 1 like that. We are taking it as a root, basically like this way. We are just breaking it like this way. So you can see like this way we are breaking. So now this is what I want: root 0 in one row, root 1 in another row, root 2 in another row. Okay, so that is what we are doing with the pattern function. So you can see this the value column is returning each person's data into a single row, right? And now what you can do, you can simply that's the reason in the query we are taking select t dot value, t dot only value column, because remaining columns we are not bothered about. So let it be as it is. I want only the value column value. So t dot value as a JSON data, and this value we are loading into another table called JSON underscore temp table. So this value columns data we are loading into another table called JSON underscore temp table. Let's execute. So once it is done, you can see JSON underscore temp table created. And now if you execute select star from JSON underscore temp, you can see each person's data are coming into a single row. Each person's data are coming into a single row, right? So for an example, this is one person's data. So now earlier, all the record was coming into a single row. Now each person's data are coming into a single row. Got it? Now what I will do, I will break it further into row column format. So first of all, what I need to do, I need to break the structure, basically static value. I will be breaking the static value. Static value in the sense, for an example, age. Age is a static value that is having only one value, single value. But children entity is not a static value. Children entity is the basically dynamic, like it is having one-to-many relationship. A children entity is having one-to-many relationship. One person can have multiple child, but one person cannot have multiple age. So age is a static value. Similarly, if you come down, then full name, gender, kind, phone number, these are all static values. So first I will break all the static value. So to break the static value, we don't need any extra function or nothing. Directly we will be fetching it. So for an example, select, then from JSON underscore temp. JSON underscore temp is nothing but this is the table we call, we name is JSON underscore temp. JSON underscore temp table, we loaded the data. So that is what we did. This is the JSON, like first we had the person table. From that person table, we take the data and we load it into the JSON underscore temp table. In JSON underscore temp table, we have each person's data into a single row. Okay. So what I'm doing, so select from JSON underscore temp D. D is the alias of this table. So this is the JSON underscore temp table. Now d dot JSON data. This is the JSON data. D dot JSON data. Okay. D dot JSON data colon full name. D dot JSON data colon full name. What does it mean? It means, understand, first we are retrieving static value. For retrieving static value, we don't need to use any extra functions and all. D means this table dot JSON data means this column, okay, colon full name. What is full name? Full name is the column of the file. So this is how we need to break D dot JSON data colon full name and double colon data type. What type of data, what type of value it is, character, number, date, what is this? So that you have to mention double colon character. So double colon varchar as full name, okay, comma. After that again D is this one dot JSON data colon age. This is integer value. Similarly D dot JSON data colon gender. D dot JSON data colon kind. Okay. D dot JSON data colon phone number. Now phone number is having two parts. One is area code, one is number. So D dot JSON data colon phone number colon area code. This will be treating as a area code one column. Now again D dot JSON data colon phone number colon number. It will be treated as a phone number that will be coming in another column. You can see here D dot JSON data colon phone number colon one step ahead colon area code. This will be treated as a area code. Similarly D dot JSON data colon phone number, again colon number one step ahead, so that will be treated as a phone number. Now if you execute this query, you will be getting the value like this way. So you can see John, age 22, male, 206 is the area code. Phone number is this. Mike, 35, male, area code is 622. Phone number is this. Anna, age is 45, female, area code is 425, and this is the phone number. Now this value you are getting from the query. Now you can insert or into the some table also. For an example, let's say I'm creating one table called person underscore details as like this way. So let's execute. So I created this table, person underscore details table. Now if you check this table value, select star from, you can see the entire person details has been, so these are all the static value. So we loaded into the person underscore details table. Okay. Similar, now I will be breaking the next one. Next one, which one? Children entity. So now all the statics value we have bring into the row column format. Now I will be breaking the child entity. So now you can see in the children entity we have multiple value. So that value I need to break. So what I will do, I will be using another function here called lateral flatten. This function will be breaking your loops inside the basically any JSON file. If you have basically any file which is having loops inside the file, that means any one-to-many relationship, that type of loops it will be breaking. So for an example, let's say I will be showing you how it looks like. Let me copy this part. I'll paste here and I will write here select c dot star. What does it mean? Before checking into the query, I will check the entire thing here. So select c dot star from JSON underscore temp table. You know that table which is having the three. Again, let me execute that. Select star from JSON underscore temp. Now you can see this is the table JSON underscore temp table. Now inside the JSON underscore temp table, we have the children entity, right? So that is what I am doing. Select from JSON underscore temp D lateral flatten. As the input, I will take which loop you want to break, children. So D is this one dot JSON data colon children. Okay. D dot JSON data colon children, that you have to take as an input. That means you are taking the children entity as an input, and after that whatever this is the lateral flatten, whatever this function will be returning, that alias of the function is C. So I'm taking C dot star, means whatever this function will be returning, all I want to see. So if I execute this, you can see how it looks like. So you can see the first person, this is the first person's data. Now first person is having two child. Okay, one is this one is this one. Second person is having three child. This one, this one, this one. Now you can see each child details are coming separately in the value column. So first person's data is having two child. This is the two child details. Second person, you can say 0, 1 index. Second person is having three child, that three child details are coming here. Now Anna, that means third person doesn't have any child, so her details are not coming here. So that's the reason I need the value column. So that is what I'm doing here. Now what I'm doing inside this query that you see here, then we'll understand. Now you can see what query we are writing here. We are writing select d.json data and full name json data, d.json data colon age. That means age and full name, these are all the value that we are taking directly from the JSON temp. This because these are all static value for the person. Why I am taking into this query also, to identify that which person's child is this. That's the reason this full name is a value that I am taking into this query also. So full name, age, okay, that we are taking like how we fetched in the last query directly, because these are all static value, these are all not the dynamic value. So that's the reason these are all static value, directly we can fetch from the JSON temp. That is what we are doing here, these two. Now next is this three value is nothing but the child details, age, gender, name. So first this lateral flatten functions alias is C. So we are taking C dot, this function is returning this value column. So C dot value colon name. that is the child name. Similarly, C dot value colon gender, that is the child gender. Okay. Similarly, C dot value colon age, that is the child age. Okay. And these details we are fetching from the lateral flatten. Now, if I execute this, you can see John is having, that's the reason I taken this age and full name here to understand that which person's child these are. So John is having two child, one is Jane, one is John. So he is female, male, and this is the age. Similarly, Mike is having three child, Earl, Sam, Kit, and these are all the details are available here. Now Anna's details are not coming here because Anna does not have any child. Now if you want to still bring the Anna's record, then what you have to do with this lateral flatten, you just have to use the outer clause. Okay, you just have to use the outer is equal to true. This is nothing but the outer query type of things. Now if you execute this query, now Anna's details also will come and this child information will come as a null. Okay, now this is the child information you fetch, and this query you can basically store record stored into another table of, let's say, person underscore child information as like this way. You can execute. So basically your person underscore child successfully, the table got created and it stored this record. So if you fetch that table, let's say select star from this table and you can check it like this way. Okay, so John, two value, similarly Mike, Anna, no value. So you got the record into the table. Okay. Similarly, and last one is the person details. Now person details also we need to break like that way only. So we will be using the lateral flatten to break the cities lived. So that is what I am doing. So you can see all the values we have taken, and I use the lateral flatten where I have taken input is equal to d.json data colon cities lived because I want to break the cities lived. Now here I use the two lateral flatten because I have two loop I need to break. One is cities lived. Now inside the cities lived, another loop is there that calls years lived. Now that's the reason in the first lateral flatten I have taken cities lived till cities lived. And because inside the cities lived we have another called years lived, that's the reason in the next lateral flatten we have taken CL. CL is referencing the returned value by this function. So CL dot value dot years lived. That is what we are doing. So now if you see how it is working, so you have to break and you have to see that basically how exactly it is returning. So every part you will, if you small part, if you break and check, so it will be easy for you to understand. So let's say if I write here, and so simple thing, if I execute this one, this query, I'm returning all the value from the CL. Now you can see the query what I'm executing. I'm returning all the value from the CL. CL is nothing but we are breaking the cities live part. Now you can see this is the first person lived in two places. This is the second person lived in multiple places, four places. Now this is the third person lived in three places. All the details are coming. And if you check any one record, this is having two value. One is place, one is years lived. Now place is a single value, so directly we are getting it. So that's the reason in this query, you can see I have taken CL. CL means this is CL dot value. Value means this column colon place. This place value we are taking directly as a place value, but that's fine. But yard slip is another loop. You can see yard slip is multiple values. So that's the reason what I did here. I used another lateral flatten where I taken CL dot value. That means CL dot value is this column colon yard slip. This yard slip I have taken here, and that value is the yard. Now this is doesn't have any key. That means no column name is there. Directly value is there. That's the reason in the select clause also I am taking yard dot value. Now you can see in this place, in if you check this one, here two part is there. One is key, one is value. One is key, one is value. But inside the yard slip, we don't have the separately key part. Only the value is there. That's the reason. Directly we are taking yard dot value, it will fetch the record. Now, in this query, we are storing into the table called person underscore place. And if you run this table, you will be getting the value like this way. You can see John lived in these two places. These are all the year. Mike lived in Los Angeles. These are all the years. Similarly, in Washington, these are all the year. Like that. So each and every values you are getting like this way. So basically, by using this function, you are breaking the entire file into the row column format. Okay, that is one thing. Now, this is the JSON file that we loaded. Now, this is one type of semi-structured file. Like if your file is having loops, if your file is having basically multiple values, like one-to-many relationship with any particular insider columns and all. So in that case, we use these functions and all. If we don't have the basically loops inside the file directly, then this lateral flatten function should not be used. Directly, we can fetch the data from the table itself. So let's say for an example, now I will be loading another file, let's say upload, and I will be loading another file called Parquet file. This is another type of semi-structured file. Let me upload. I'm uploading into the same folder. Okay. Now you can see I uploaded. If I go here, you can see the JSON file got uploaded. Now similarly, Parquet file also got uploaded. Okay. Now what I will do, I will read this Parquet file and load the data into the table. So how we'll do that? So simple thing, I will write the code here itself. So first, what you have to do, you have to create a new table which will be loading this Parquet data, right? The Parquet file name is ABA block. So I'm just creating a table. Let's say, okay, let's copy this one. Let's say this table name I'm writing as a block. Okay, so and the data and the column name is a block data variant. So first I have to do this thing. I created another table called block where I will be loading the Parquet file data. Okay, now here I am loading Parquet data, so I need to create the file format as well, because JSON format won't be working with the Parquet. So here I have to write Parquet. Okay, and this name will be different. So for an example, let's say Parquet underscore format, type is equal to Parquet. Let's create it. So Parquet underscore format got created. Okay. Now let's say I'm writing here another stage I'm creating. So create or replace stage, external Parquet stage. So folder path will be same, but remember here, because we are creating another Parquet, so here instead of file format JSON underscore format, we will be using the Parquet underscore format, because new file format created, so that new file format will be utilized. So let's create the stage. Now I created the stage. Now what I will do, I will load the data. So copy into block table from this stage. Now remember one thing, whenever I will execute list at this stage, so basically how many files we are able to see? Two files we are able to see. Because in this folder, I have two files. One is JSON, one is Parquet. Now I don't want to load JSON file to the block table, right? I want to load Parquet file to the block table. But if I load as it is like this way, then what will happen? Both the file will be trying to load into the block table, and I will get error. Why? Because I use this stage, and this stage file format is Parquet format. So whenever JSON file will try to load into the block table, it will get an error. So to eliminate that one, so what I will do here, I will write here pattern clause. Pattern clause means you can mention here that which type of files you want to load into this table. For an example, in the pattern clause, I will write here, let's say dot star Parquet dot star. That means the file which is having this Parquet keyword, that file I want to load into this table. So that is what the pattern clause. Pattern clause takes the regular expression, and by using that, it will be scanning your files. So in any file in this folder is having the parquet keyword, that will be loaded into this table. Okay, so let's execute. Now you can see the entire record has been loaded. Now what I'll see, I'll go to the block table here, and now you can see all the records has been loaded. Now you can see all the record has been loaded here. And once the record has been loaded, let's say, let me copy any one of the record from here, and let's paste here. Now you can see this file doesn't have any loop, nothing, all the direct input, all the direct value. So in this case, you don't need to go for any internal function utilization. For an example, how will you break that data here? Directly. So select B dot, block data is the column, then colon. Let's say I want to take this column. So let's copy and paste as this one. Okay. Now after that, B dot block data, then again colon. Let's say I want to take this column. Let's copy and paste here as this one, comma. Again, let's say B dot block data colon. Let's say this one. Okay, as this one. And again, B dot, let's say block data colon. Let's say I want to take hash. Anything you can take, like that is not only, that is a parent hash. I want to take this column. I don't want to take all columns. I want to take this column. Let's say here I'm writing as and this. And after that, if you execute this query, you will be getting your values like this way. You can see row column format. So here you don't need to use any function or nothing. So directly you can fetch the data by using the query itself, because you don't have any loops inside the file. Okay. So this is how we load the semi-structured data. Okay. Now any type of format, if you give any type of format, Avro, WRC, whatever format, just you have to create the separate file format for that particular formatted file. If you're giving Avro, you have to write here Avro. If it is giving ORC, you have to write here ORC. And similar way, you have to create the stage also, separate stage for the each type of files. And then you have to load the data. That's it. Okay. This is how the data loads, semi-structured data loads into the table. Now, another thing I will show you. For an example, let's say till now, whatever thing we did, we already, so any question, any doubt in the semi-structured data loading part here? Okay, all good. Fine. So till now, yesterday and today, whatever example we have seen, what I did. So first I loaded the data into the AWS. Then I executed the copy statement manually, and I loaded the data into table. That is what I did. I loaded the file into AWS. Then I executed the copy statement manually, and then I loaded the data from the AWS to the table. Like that way we did, right? Now, every time I load the data file to the AWS, I executed this copy statement manually. Now I will not do that. What I will do, whenever I will load the file into AWS, I want automatically the data will be loaded to my table. And that will be possible by using the pipe object. So instead of that copy, I will be creating one pipe object here. And that pipe object will be loading my data into this table. This copy statement I will write as a definition of this pipe object. So this pipe object will be working on behalf of us. it will be loading the data from the AWS to the table by using this copy statement. Okay. So that is what I will do. Now this pipe object is nothing but it is a Snowflake database object. So let's see how it works. And remember, this is a serverless features. We already have discussed that we have in our classes that we have a one serverless features we already have discussed, like automated reclustering. Whenever we created a cluster key, the table gets reclustered automatically. We have seen this example, hope you remember, and that was a serverless features. So you might have seen that whenever we was executing any query, any copy statement, we always use the virtual warehouses, because copy statement needs the virtual warehouse to be utilized. Copy statement is actually loading the data, and that's the reason it is needs the virtual warehouses. Now, whenever any serverless features will be utilized, that will not use any of the virtual warehouses from your account. It will be using their own dedicated servers, and by using that Snowflake managed resources they will be using, and that data loading will happen automatically from the background, and it will not load anything on your existing virtual warehouses. That's the reason we call it as a serverless features. And here one serverless feature called Snowpipe will be utilized. Your object name is pipe, and serverless features by which pipe will be loading the data to the table, that Snowflake, that resource we called as a Snowpipe, or you can call it as a serverless feature, or you can call it as a Snowflake managed resource. Whenever we will be loading the data, after that this Snowpipe will be added to your account consumption, and whatever cost it will be charging you, that will be added there. Okay, so like that. So simple thing, I'm creating one file database called load file, and I'm creating one table called student underscore CSV. Any data you can load, not only CSV, CSV, JSON, Parquet, anything. So I'll show you. For an example, let's say student underscore CSV, I created one table. I'm creating one file format here. So let's create the file format. I'm doing it fast because these are all things already we have seen. And after that, I'll go to this bucket, and here I will create another folder called pipe. Let's say pipe, another folder. I'm creating one pipe. Okay, now I want whatever files I will be loading into the pipe folder, that will automatically load to your table. So let me copy the URI, and from here, so basically I will paste this URL here. So let me paste, and after that create the stage. So stage created. If I write this one, as of now the stage doesn't have any value because no files has been loaded to this pipe folder. So that's the reason nothing is showing from that down. And after that, what I'll do, I will create the pipe object. So yesterday we have seen with the continue. Today we will see with the keep file. So for an example, create or replace pipe name auto ingest is equal to true. Auto ingest is nothing but automatically the data will be loaded to the table. Auto ingest is equal to true. So this is the pipe name, this is the pipe object, and inside the definition of the pipe I will write the entire copy statement. Whatever copy statement you want to execute, that you have to write as the definition of the pipe. So I'm writing the copy into student underscore CSV from the external stage on error is equal to skip file. So you remember what is skip file will do. Skip file, if any error comes into the file, all the error will be removed. So basically no data from the file will be loaded. So that is the reason skip file. So for an example, I'm creating this pipe object. So pipe is an database object. Let's create the pipe object. Once I created the pipe object, so you can see here, this is the schema, and inside the schema you have table, stage, file format. And now if I refresh, what happened? So the pipe successfully created. Let me refresh it again. Some problem is there. Pipe object is not showing here. Anyways, let me. So this pipe object got created. Now, if you check the show pipes here, now we will be seeing this pipe object has been created inside this database, inside this schema. Okay. So this pipe object has been created inside this load file database, inside this public schema. And definition is also the entire copy statement that you have written. Okay. Now what is the situation? Now I have the AWS here. I have the pipe object created and I have the table also. Okay. Now I need to set up a notification. What is the notification? I whenever a file I will be loading to the AWS folder or AWS bucket, so this pipe should get a notification. Whenever a file will be loaded to the AWS, a pipe will get a notification. Whenever the pipe will get a notification, then only it will be able to understand that, okay, the file has been loaded. Otherwise, how the pipe will understand that file has been loaded or not? Because whenever a file will be loaded, immediately that will be loaded to a table by using pipe. Now pipe has to understand that whether the pipe has been reached to the AWS folder or not. So that's the reason we have to set up a notification channel. So we'll go to the AWS site. I'll go to the bucket site, not in the folder properties. I'll go to the bucket property. So this is the bucket. Inside this bucket, we have these folders. I'll go to the bucket properties. And if you go down, you have a option called event notification. We will go and we will create an event notification. Here you can write the name. Let's say, for an example, any name you can give. So Snowflake ADM bucket or something like that. I am giving the name. Now after that you can come down, and when you want to get the notification, I want to get the notification whenever any object will be created. So here other options are also there, like object removal. You want to get a notification? No, I want to get a notification whenever a new file will be loaded. That means object will be created, means a new file will be loaded to that particular folder. So that is the reason. So I want to get all object create events. So basically whenever a new file will be loaded to that folder, I want to get that notification. So that is the reason I chosen this one. After that, directly we will come down and we will go to the destination section. In the destination section, we will choose SQS queue. This is a queue. This is the messaging services. SQS queue is nothing but it. So what I told you that whenever a file will be loaded, the pipe should get a notification, right? Now that notification it will receive through this SQS queue. You can see send notifications to an SQS queue to be read by the servers. So by using so it will send the notification to the pipe through the SQS queue. Okay. And here I will be choosing in the specify SQS queue part, I will be choosing enter SQS queue ARN. Okay. And here what I will do, whenever I created the pipe, after that I will execute the show pipe statement. And whenever we will execute the show pipe statement, so if you go on the right side, one notification channel will be created. I'm repeating again. Once I created the pipe, after that I will execute show pipe statement. I will be getting a notification channel string. That string I will be copying from here, and in the SQS queue ARN I will be pasting that string, and I will save the changes. Okay. So once the changes has been saved, now you can go to the object, you can go to the pipe here. So basically now all the setup is done. Now pipe has been created, everything is done. If you want to see the pipe status, you can use select system $pipe status, and pipe name you can mention. So you can see the pipe is in running mode. All are fine. Now I will upload here some files. Let me upload. Let's go to the upload, and Let me upload a first file, student.csv, and let's upload it. Now the pipe, this folder got this file, automatically it will be fired and the data will be loaded into the underlying table. So what is the table? Table name is student underscore CSV. If you see this table, you will be getting the data after some time. So let me select the virtual warehouse because you need to fetch the data from the table. So you need the virtual warehouse. So you can see this virtual warehouse is in suspended mode. So no virtual warehouse will be used from your account to load the data. So if you check the pipe status again, you can see, okay, till now it is not picked up. So let me wait for some time. Files is there. Why it is taking time? I think today it's taking little time. Till now, no copy has been sent. No error has been running. No data has been loaded. And the file has not picked anything. As of now, you can see. No, from here, you will be able to see that whether that file has received anything or not. So let me check. So this is the notification channel and all. Anyway, so it's taking time. We will try to see it tomorrow as well. So let's close it and we'll check it tomorrow. Another time I'll check it. Now it is uploaded. Now you can see it has taken your file student.csv. It was taking some time, so it has taken your file. Now you can see if you check your table here, you can see the data has been loaded successfully. So this is how the data will be loaded automatically. Let's say after some time again I'm uploading another file. Let's say I'm uploading another file. So let's say now I'm uploading student error file and I'm uploading student underscore v1.csv file. This is the two file that I'm uploading. Let me upload. Now whenever I uploaded these two file here, you can see this file already uploaded, so it will not load again, but this two file will be loaded here. So now you can see here 24 record is there. Now if you check the pipe status, let me check. Now here we are not doing anything. Automatically the data will be loaded. You can see student underscore v1.csv has been picked up. Next file has been picked up and it will be loaded to this table. 24 record was there. Now if you check 38 record is there. So automatically loaded the file. Now if you get any error, that you can check with the this function validate pipe load. If you get any error while working with the pipe, yesterday whenever we did the manual data loading, we use the validate function.
Now today, whenever you are doing the pipe data loading, we can use the validate pipe load function. And here you have to pass the pipe name and the start time from when you want to check the status. Let's say here I use the date add function with the -1 as an hour. That means actually simply we can say like I am taking last 1 hour, whatever loading happened, is there any error or not? So if you check, we will be seeing that error is there. 3 error has been came. And also if you check the copy history, the same way you can check the copy history function also. Now copy history function tell you that what is the files has been loaded and which file got error. Now student underscore error file, if you go on the right side, you can see load failed. Why? Because you have taken skip file option here. If you would have taken continue, it will be showing partially loaded like yesterday. But it is showing skip. We have taken skip file. That's the reason it is taking load failed option. And because of this file, whatever data has been rejected, that it will be getting in the validate pipe load function. Okay, like that. So this is how your Snowpipe. This is what we call Snowpipe. As I told you, this is a pipe features. By using pipe, we can automate the data loading part. I will show you the another automation part in future, like with procedure and all. So as of now, practice this one and let me know if you face any difficulties. Okay. Fine. Any doubt, any question? All good? Fine. Already time's up. Thank you. We'll join again tomorrow. Okay. Thank you guys. Bye-bye.
Thank you.
The meeting has ended. Thank you for joining. Goodbye.